Welcome to the second lecture of Module 1, Understanding Data and Statistics. If you have not gotten the textbook, please do so at your earliest convenience. I will model the lectures to some sections of the textbook, but you are expected to read the textbook material to deepen your own understanding. The first learning objective is to distinguish between quantitative and qualitative data. The second learning objective is to distinguish among the four types of measurement of data. The third learning objective is to understand descriptive statistics. The fourth learning objective is to appreciate inferential statistics. In the last introductory lecture, you learned about statistics and how it's the process of collecting, analyzing, interpreting, and presenting data. But what do we mean by data? Given the latest technological advances, we are exposed to data everywhere. We see data being transferred through our computers, iPads, cell phones, and iWatches. Whenever you send an email, you are sending data to another person through text or pictures. Whenever you post a video on YouTube or through some other site, you are sending data. Now, the big question is, where does big data come from? Let's go ahead and watch the following clip so we can visualize this a little better.
Think you're obsessed with your smartphone? Wait until you hear how much it thinks about you. Like any good motivational speaker, the internet comes from humble beginnings. It comes from ARPANET. That's the first computer network, and originally there were just two computers connected to it. But it crashed the very first time they tried to send a one-word message across. In fact, it crashed after they typed in 3 whole letters. Flash forward about 50 years or so, and now the average person is producing huge amounts of digital information through things like internet searches, online purchases, email, social media, and all of that information is being stored on server farms, which leads us to ask the question, why would anyone do that? I mean, who really cares that I'm about to watch yet another cat video, or that I tweeted 6 times during last week's Game of Thrones? Winter is coming. Corporations and governments, that's who. And big data is what makes it all possible. Now, I know what you're thinking, big data, that's a giant android who does not use contractions. No, we're actually talking about the huge amount of information generated by the internet and our ability to sift through it and make sense of it all. Do you want to see big data in action? Well, in 2000, the Sloan Digital Sky Survey was able to generate more information about our universe in a few weeks than we had accumulated in the history of astronomy. And in 2008, Google was able to predict flu outbreaks by tracking searches for things like flu symptoms and where to buy a thermometer. And if you've ever bought anything online, you've probably also seen the "you may also be interested in" message. That's not generated by some creepy guy sitting in a back room watching your every move. Those are generated from algorithms that are based upon what you've liked, what you've bought, and how long you've looked at it. And big data is about way more than just discounts. From business to the environment to education, big data offers exciting possibilities. Even the boys in blue will benefit. Data scientists are working with police departments to develop crime prediction algorithms to prevent crimes like burglaries, which, when they happen, tend to be followed by more burglaries soon afterward in the same area. The algorithm will pinpoint where and when more burglaries are likely to occur so cops can disrupt them before they even take place. Big data could also help power companies and their customers conserve energy. For example, it might send a message from a malfunctioning meter to the power company so it goes out and repairs it. Or maybe you get an app on your phone that tells you when you're wasting too much energy, like you should really close that fridge door already. Kids in school could benefit from big data, which could track their grades to such a subtle degree they could detect when a kid is having trouble before a teacher could even notice, letting the teacher step in and help the kid succeed. Although big data is really exciting, I have to admit it's a little scary too. I mean, do we really want a judicial system that's based on computer algorithms? where prosecutors and police look not for probable cause, but, as one expert put it, for probabilistic cause. The cops could come in and bust you for a crime you would have committed. You know, Minority Report style. One estimate sets the amount of data that's just floating around out there by 2020 to be 100 zettabytes, which is about 107 billion terabytes. It's a lot of cat videos.
So as you can see, the internet has played a large role in the process of big data. Now, what do we do with all of this data? Those who know how to use and analyze it constructively will benefit greatly from the information provided by this valuable data. Now, where can we obtain data from? First, we can get data from existing sources. We can find data using a company's internal records. We can search Google for any company's internal records to obtain data. Many companies, such as Starbucks, have large databases that store their employee records, sales records, and customer satisfaction records. This information is useful because, as a manager or even as a CEO of a company, you can keep track of a company's overall performance. You can also obtain data from a company's external records. Some companies have leasing arrangements and they post their information on local or national newspapers. For instance, Bloomberg releases external records so that stockholders may monitor their stock's performance. You can also obtain data from other resources such as the internet and government agencies. For example, the Census Bureau provides plenty of data about the nation's economical growth, emergency preparedness, house sales, and job outlook. Second, you can obtain data from statistical studies. You can start with a question or a hypothesis that you have about a particular topic of interest relevant to your field, and develop your own experimental or observational study to collect new data about a sample. This is an approach that I often take. As a professor, I collect my own data to develop my own statistical studies about areas that fascinate me. Some of you might be expected to conduct your own independent studies with a professor so that you can present or publish your work in a journal relevant to your selected field. There are two types of data. We have quantitative data and we have qualitative data. Quantitative data refers to the numeric values that indicate how much of something. If you step into a scale in the morning, it will give you a number. If you wear a fitness tracker watch throughout your day, it will tell you your heart rate, the calories that you're burning off, and even the time of the day. These devices will provide you with quantitative data about yourself. From a company's perspective, quantitative data can refer to the amount of money made in one day, or the number of customers that walked into a particular store. Qualitative data, on the other hand, refers to labels or names used to identify an attribute of each element. Think about your name. Is your name qualitative data or quantitative data about yourself? From this definition, your name is qualitative data about yourself. Think about the name of your favorite coffee shop or the name of your favorite TV show. My favorite coffee shop is Starbucks, and one of my favorite TV shows is That 70s Show. These names are labels, and they are qualitative data. Once we have data, we need to measure it. Measurement is the process of determining the existence, characteristics, size, and/or quantity of changes in a variable through systematic recording and organization of the researcher's experimentations or observations of data. In order to measure data, we need to be able to describe the variability of a variable. By variable, we are talking about a concept that we're interested in studying. For instance, a quantitative variable can be weight or income, and these variables vary over time. There are 4 different levels of measurement. A measurement scale is a specific scheme for assigning numbers or symbols to designate characteristics of a variable. For instance, how would you measure your success in school? To measure your success at school, you might use a quantitative scale such as grades. You might monitor your grades to maintain a particular GPA. If you wanted to measure success using a qualitative scale, you might draw a picture of what success in school means to you. It might be more about the social connections you're making or how you label the emotions that you encounter as you overcome a set of educational challenges. For instance, you might label your educational experience as challenging but also rewarding. Let's go over the 4 different types of measurement scales. The first type are called nominal or categorical scales. These scales serve to classify variables into at least 2 different categories, labels, or names. For instance, let's say we have political party as a variable in our study. We know that political party has separate categories within it, which can include Democrat, Republican, Independent, or Libertarian. If we have religion as a variable in our study, then we can classify the categories from within: Christian, Catholic, Jewish, Muslim, and so forth. If we have international business type as a variable in our study, then we can classify the categories into agriculture, mining, real estate, financial, and manufacturing. Another type of scale are called ordinal scales. These scales classify variables in nominal categories, and they also rank the order of these categories along some dimension. For instance, if grades was a variable, we could rank the grades alphabetically from A to F. Notice how these are also categorical. Some students will earn A's, some C's, and so forth. If we had quality of business service as a variable, we can have 3 categories: poor, good, and excellent. And we could also rank them in order. If we had class level, we could categorize a student body as freshman, sophomore, junior, and senior. But these categories are also in the proper subsequent order. An easy way to remember ordinal scales is to think about the word order and how a categorical variable can be ordered. Another type of measurement scale are called interval or numerical scales, which categorize and rank variables, but also establish equal distances between each adjacent point along a measurement scale with a fixed unit of measure. Have you ever seen a ruler? It has 12 inches, but each inch has the same exact equal distance from 1 inch to the next. This principle works with other variables as well. For instance, we can have the variable monthly income and have it set up so that we categorize individuals according to their monthly income. For instance, some individuals will make $5,000, others $10,000, maybe others $15,000. Notice how each number here is equal in numerical distance. The difference here is $5,000. Person 2 makes more than person 1. How so? By $5,000. Let's look at another variable, SAT scores. SAT scores can also have equal distances between each adjacent point. Person 1 here got a 650, person 2 got a 550, and person 3 got a 450. Notice how there's a 100-point difference across the persons. This is what we call equal distances between each adjacent point. Lastly, let's look at Canyon's temperature. It is predicted that it will be 59 degrees on Monday and 57 degrees on Tuesday. Notice how these weather temperatures are separated by only 1 degree. The last measurement type of scale are called racial or numerical scales, which categorize, rank the order along a scale with equal intervals, but also establish an absolute or true 0 point where the variable being measured ceases to exist. This means that negative numbers do not exist in racial scales. Here, we can ask specific questions to obtain racial type of data. For instance, we can ask questions using a survey to students at West Texas A&M. We can ask them, how much did your first car cost? This question will yield a racial type of response. My first vehicle cost $2,000 and it was a white Dodge Stratus. We can also ask a different question. How many tacos did Taco Bella sell this week in comparison to last week? By asking this question, we can obtain a number to determine how sales went in comparison to last week. We can also ask, how many hours a week do you study per week? Depending on the student that you ask, some might say 2 hours a week, and another might say 20 hours a week. Now let us take this brief quiz to assess our understanding. Please indicate which type of scale is indicated in the following variables: nominal, ordinal, interval, or racial. The numbers assigned to runners. These are individuals in a marathon and they are assigned random numbers. Would this be nominal, ordinal, interval, or racial? Now, the rank order of winners: third place, second place, and first place. Would this be nominal, ordinal, interval, or racial? How about the performance rating on a 0 to 10 scale? Here we have 8.2, 9.1, and 9.6. Would this be nominal, ordinal, interval, or racial? Lastly, the time it took the runners to finish the race. Here we have 15.2, 14.1, and 13.4. Would this be nominal, ordinal, interval, or racial? So let's see how you did. The first one is nominal because runners are labeled by these numbers. The second one is ordinal because the runners are ranked in a particular order. The third one is interval because there are equal distances from 0 to 1, from 1 to 2, from 9 to 10 in the measurement scale of 0 to 10. And the fourth one is racial because you're just dealing with the numbers. So now that you know about the 4 types of measurement scales, how can we adopt these measurement scales to create questions to design our own Qualtrics survey? Let's watch this clip to introduce to you how Qualtrics is used to develop company surveys.
A wise man once said,
"Knowledge is power."
"You couldn't be more right, Sir Francis Bacon. Knowledge is power. Knowledge gives you the power to understand your customers, the power to exceed expectations, and the power to make decisions with confidence." Welcome to Qualtrics Research Suite, the industry leader in enterprise data collection. Research Suite helps you collect data, customer insights, product feedback, market research, and customer satisfaction on the most powerful survey-based platform in the world. In short, we make sophisticated research simple. Our survey solution helps you easily build, send, analyze, and act on valuable insights. Maybe that's why over 5,000 organizations, including 97 of the top 100 business schools and over half of Fortune 100 companies, already use Qualtrics Research Suite. Maybe it's because Research Suite has the most advanced features available, like point-and-click design, endless question types, custom branding, data exports, advanced reporting, and award-winning customer support and training. What do you want to know? Want to know about a new product or service? Measure customer experiences and satisfaction across touchpoints? Or gather feedback from any constituent? Qualtrics Research Suite delivers the real-time insight that will allow you to outsmart your competition. So now you know, and knowing is half the battle.
Good show.
Know more. Do more. With the power of Research Suite. Come on, let's get started.
So would you be interested in working with Qualtrics to do your own survey? So how can we adopt these measurement scales to create questions to design a Qualtrics survey? So I'll go ahead and show you my Qualtrics page by the College of Business at West Texas A&M University. Feel free to sign up for your own account. This is provided free by the university. Just make sure you use your correct West Texas A&M University email. So how would I create a basic survey? So the first thing I would want to do once I get to this page is click on Create Survey. Once you do that, you will have options. Don't worry so much about copy, because if you don't have previous questionnaires, this will not be useful. Survey Library will allow you to use others' survey templates using a variety of different categories. For us, let's go ahead and click Quick Survey Builder. Survey name, let's write up Survey Spring 2016. Don't worry about the folder. Create Survey. It will take a couple of seconds. Now, let's create a couple of questions for illustrative purposes. First off, create a new question here. Let's write a nominal type of question, which would be, what is your sex? Why is this nominal? Because you give participants two categorical options, male, female. Let's go ahead and create another new question. This time, let's get a little bit more involved. So let's click here. We see a variety of different options that we have. So we covered ordinal measurement scales. So let's click on rank order. Let's create a type of question that we might be interested in. Rank the following companies. So let's put a dot there. The first one, let's put Apple. Second one, Microsoft. The third, Dell. So this allows participants to move these around according to how they're ranking these companies. Now, let's create another one. Let's create a racial type of question. For this one, let's click text entry. We could ask individuals, how old are you? Just basic. And that way participants can put how old they are here numerically speaking. So let's just say a person says 11, but that's what they will be doing. Let's create one last one, which will be the most challenging one, but it's also the most useful one, which is the interval type of measure. So let's click change question type. I like to use the matrix table. Why? Because it allows us to use equal adjacent points. So let's click it here. So here, let's put a question. Let's put a basic question such as, on a scale of 1 to 7, how satisfied are you with the following products? So let's write 3 different products. I'll put tablet, cell phone, and here let's put computer. So nicely, here we have very dissatisfied. If you think about it numerically speaking, this would be 1, 2, 3, 4, 5, 6, 7. So that's why it's an interval. And that way participants can just click here, 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 wherever they want. Or they could switch their mind, that kind of thing. So now let's say that we're done. If we're done, what do we need to do? Well, it's rather simple. You don't even have to push any save button or anything. It does it automatically. That's what's nice. So let's just preview our survey. So that we push the preview button. And you'll see that this is what it will look like. What is your sex? Male, female. Rank the following companies. There they are. See, I could rank them. And I could input how old I am and my satisfaction with these products. The nice part about Qualtrics is that you can take these surveys using your tablet or cell phone as well, which is kind of nice. So it's very technological friendly. So how would I publish it? All I gotta do is click Launch Survey. When I do this, I will push Activate Survey. By doing this, it gives me an anonymous survey link so I could give it to all my friends. Let's say I post this on my Facebook page or my LinkedIn and I ask, hey everyone, please complete this survey for me. As long as they have this link, anybody could complete it. Now for research standard purposes, you would need IRB approval, which means that you need to go through a whole process. But if you're just doing it for a company or for personal reasons, you can develop any survey whenever you want. So as I just suggested there, you could create your own surveys. But now, another important question to ask is, how frequently can we collect data from the same participants using a survey approach? Cross-sectional refers to collecting data only once from a set of participants. For instance, let's examine this study of the millennials and the workplace in 2015. If we were to distribute our survey comparing millennials to Generation X only one time, then we have collected cross-sectional data. In this study, we can see that Generation X members are likely to report being team players. And we can see that millennials are more likely to be narcissistic, open to change, creative, adaptable, and entrepreneurial. Now, would you agree or disagree with this cross-sectional study's findings? Here's where your critical thinking skills come to play. If this is data from only one study, remain skeptical. This doesn't mean it's always true. It might have been the case for that one sample at that specific point in time, but this might not always be the case. However, many researchers prefer the use of cross-sectional data because it's cheap and easy to do so. This is why many scholars conduct time series data collection processes. When we do a time series approach, we collect data more than one time, maybe 2 or more times across the same sample. For instance, the Census Bureau and the Pew Statistics conduct series of studies on issues such as the unemployment rate in America to get a larger picture of how the data shifts up and down across the years. The time series approach yields higher quality data arguments, but it's very expensive and it takes a lot of rigorous work. There are also two types of statistics: descriptive and inferential statistics. Descriptive statistics are summaries of data which may be tabular, graphical, or numerical. Bar graphs are commonly used to visualize data. For instance, here we see a study conducted in February 2013, which indicated that in that period of time, Internet Explorer used to be the best desktop browser and Firefox was the second. How has this changed? We would need to collect data and develop our own bar graph to find out. Histograms are also useful to visualize particular variables. Let's take receptionist phone calls for example. Note that contribution statements are the most common type of phone calls, but job applicants are the least type of phone calls that receptionists get at the office. Once we have data, we make inferences or interpretations about a given population of interest. For instance, a population is the set of all elements of interest in a particular study. So let's say my target population of interest is Costco customers across the United States. This will be similar to taking a census. When we're dealing with a larger national population, we can see the visual that there will be many different individuals. However, because it's not always possible to survey the entire nation, we can collect data from a population sample, which is a subset of the population of interest. So let's say that Costco customers from 4 states complete a survey about their satisfaction with Costco. From this data, from this smaller sample, which you can see visually here as a small sample of the whole, we can make inferences about the larger population, which in this case is the nation. Whenever we sample a larger population, we are taking a small sample of the whole, just like we would try a new ice cream with a spoon to determine if we want to purchase an entire bucket of ice cream. Also, to avoid bias in our study, it's important that we have random samples. These are elements in a selected sample that have an equal chance of being included, such as voters, companies, products, and customers. In our example, to reduce bias, we need to make sure every single Costco customer has a fair shot at taking our survey. While not everyone would choose to take our survey, each survey taker has an equal chance of taking it. A statistical inference is defined as the process of using data from a sample to make estimates and to test hypotheses about the characteristics of a population. In other words, we're making assumptions about a larger population from the data we obtain from a smaller sample. Now, let's examine this table. Let's take a couple of moments to see what inferences or interpretations we can make from this sample's data about the larger U.S. population. So here we see burnout index comparing physicians and U.S. workers. You see a few variables and the comparisons. So let's look at the 5 variables here. In emotional exhaustion, we can see that there are minor differences in physicians and U.S. workers' emotional exhaustion rates. Physicians reported a bit more of depersonalization than U.S. workers. Also, we see that physicians report higher rates and burnout than U.S. workers. We can also see that they are quite similar in their depression and suicidal ideation. But we also note that U.S. workers are more satisfied with their work-life balance than the physicians were. As you can see, making statistical inferences focuses on how you make sense of the data from your study. Only you can do that. No machine can do that for you. The numbers will provide you with data, but you need to make sense of what that data means to you, conceptually speaking. Because human beings are the ones making inferences about the data, we need to be careful not to use our interpretations unethically. We should strive to report our statistics with high integrity so that we build confidence in our studies. Several researchers have got caught for lying with statistics by reporting made-up data or by biasing their interpretations for their own benefit. Some companies even hire researchers to conduct biased studies just to support inaccurate statements that their products are better than others out in the market. It's important that we all try to be fair, thorough, objective, and neutral whenever we're handling data. This means during the whole process. The process of collecting it, conducting the analysis, making oral presentations, or writing reports of the data. Also, be highly skeptical of any statistics that you see on television, the internet, the newspaper, or by politicians. Whenever you encounter a statistic, be skeptical and do not think that it's the absolute truth. Numbers change very rapidly, sometimes even by the day and time. So remain skeptical and strive to be objective so you can see the full picture. I recommend that you read or listen to Darrell Huff's How to Lie with Statistics to help you become more skeptical about statistics that you often hear about in the media. Unfortunately, many individuals believe any number that they see that comes from a politician's mouth, a journalist's mouth, even if it's biased and highly misleading. Overall, this concludes the first lecture of data and statistics. By now, you should understand how to distinguish between quantitative and qualitative data, and how to distinguish among the 4 types of measurement of data. You should also understand the basics of descriptive statistics and inferential statistics, and how to apply ethics when making your own inferences about statistics. Now, the next time you hear a statistic, whether it's from the news, newspaper, blog, or the television, practice skepticism and begin to ask yourself, how was this data collected? What researchers designed this study? Why is this specific data being revealed to me? Why now? What data is not being revealed to me? Is this data biased? These type of questions will make you a better critical thinker.